Alright, so our next question is coming from OWN 4.21. We're going to do number D first. Number D, letter D. So, it gives x of t as the summation of a sub k times the delta function of t minus kt. Okay, so when you're computing a Fourier transform, you're given x of t and you want to find x of j omega. Okay? And with a bunch of practice, you should already know x of j omega is going to be equal to the integral of your domain x of t times e negative j omega t with respect to t. Okay? So our x of t, this is equal to x of t. Okay? So this is going to be the integral of t. So x of t is going to be the sum. Oops, that's not a summation signal. E infinity 0 a sub k delta of t minus kt. Jesus. E j omega t negative j omega t dt. Alright, I bet you're wondering, you're like, man, what the heck? I don't know how to take the integral of a summation. Well, that's cool, because you don't need to. That is a constant, so you can take it out. Okay? So t summation infinity to 0 a sub k. Then you're just left with delta t minus kt e negative j omega t dt. Alright, so this is going to be quite easy right here. Okay, so first you need to find your domain t, and this is going to be continuous from negative infinity to infinity. Okay, so you have infinity 0 negative infinity to infinity delta t minus kt e negative j omega t dt. Okay, and when you're taking the integral of of a delta function times anything else, the result is whatever's in the integral minus the delta function. So the result is going to be, don't forget your a sub k, summation 0 a sub k times e to the negative j omega t at kt. Okay? And the reason it is at kt is because the delta function is only valid at a value of kt. Okay? Because, let's draw it out for you. So you know the delta function looks like this. Okay? And every kt value, there's one of these multiplied by the e negative j omega naught, or omega t. Okay, so it is now going to be equal to the summation infinity 0 a k times e negative j omega k t. Alright, and this is shaping up to look like a geoseries. So the summation infinity to 0 a k, we don't want to do that, we want to take it out, a times e negative j omega big T all raised to the k. And with your geoseries formula, b to the 0 minus b to the n plus 1 over 1 minus b, that is going to give us, so e to the 0 is going to be 1, and then e to the negative infinity, because we're going from 0 to infinity, so n plus 1, infinity plus 1 is still infinity, times negative j. It's going to be e to the negative infinity, which is going to be equal to 0, all divided by 1 minus a e negative j omega big T. Okay, so your final answer is going to be 1 over 1 minus a e negative j omega big T. All right. So hopefully that was helpful. All right, so our next question comes from 4.21e. Compute the Fourier transform of the following signal. So x of t is given to us by this. All right, and when you're computing a Fourier transform, we know that we need to find x of j omega, which is equal to the integral of the domain x of t times e negative j omega t with respect to t. Okay, so immediately I can see that part of my x of t signal is a sine function that I'm going to have to multiply by multiple e functions and take the integral of it, which I do not want to do. Okay, so we're going to change this by using Euler's. Okay, so sine 4t is going to be equal to e to the j 4t minus e negative j 4t all divided by 2j. Okay, so that's our new replacement for the sine 4t. Okay, so let's go down here and plug it in. So t of t e negative 2t times e 4jt minus e negative j 4jt divided by 2j, still multiplying by e to negative j omega t with respect to t. Okay, and you're probably wondering why I have left this out. So that use of t function is basically a domain operator for you. Okay, so we know that use of t is only valid from 0 to infinity. It goes like this, okay? So since everything else in x of t is multiplied by that, anything this way of it equals 0, and anything this way of it is just multiplied by 1, okay? So that sets the domain 0 to infinity, okay? So that's what is going to be put in to our integral for the domain. Okay, so let's just go ahead and make that 0 to infinity. Okay, so now the awful part is distributing all of this. Okay, so let's just go ahead and do it. T e to the t out 4j minus 2t minus j omega. Okay, so that got this. Okay, and we're actually going to move the 2j out on the bottom because it's a constant. Okay, and then minus t again, e to the t negative 2 minus, actually we'll keep the same things, minus 4j minus 2 minus j omega. Okay? So now we actually have to take the integral of these two. We're going to separate that, make it much easier. Okay? So the integral, did I leave a t in there? What am I doing? Okay. Right, so the integral of this one, you have to do integration by parts. Okay, so u is going to equal t, so du is going to be equal to 1. dv is going to be equal to e to the t 4j minus 2 minus j omega. V is going to be equal to e to the t 4j minus 2 minus j omega, all divided by 4j minus 2 minus j omega. Okay, and we know the formula for this is uv minus integral of v du. Okay. Alright, we're going to move this because we're going to set the variables for the other one. So we're going to just color code this so it's much easier to follow along with. And this one, mark as red. This one's u is going to be equal to, we're just going to leave the negative sign out there and don't mess with it. So it's going to be t du is going to equal to 1. dv to be equal to e to the t minus 4j minus 2 minus j omega. V is going to equal to e t is 4j minus 2 minus j omega, all divided by minus 4j minus 2 minus j omega. And color code this so you can understand what's going on with what. Okay, so this is going to be a long process here. Alright, so first one, u times v, so it's going to be t times e to the t 4j minus 2 minus j omega, all divided by 2j. Actually, we're going to leave it out. Over 2j. We're just going to multiply that by everything at the end, okay? 4j minus 2 minus j omega. Okay. And that's going to be from 0 to infinity minus the integral from 0 to infinity of v du. So du is just going to be 1, so we're not going to worry about it. V is e to the t 4j minus 2 minus j omega divided by 4j minus 2 minus j omega. Okay, so this is the purple part. Now we're moving on to the red part. Minus 1 over 2j. So u times v is going to be t e to the t minus 4j minus 2 minus j omega, all divided by negative 4j minus 2 minus j omega, from 0 to infinity, minus. So what I'm going to do is, so I don't get confused later, I'm just going to go ahead and distribute this right now, okay? Plus, minus, plus, okay? And then this is going to be the interval from 0 to infinity. Du is equal to 1, or yeah, e is equal to 1, so we're not going to worry about it. E to the t, negative 4j minus 2 minus j omega, all divided by negative 4j minus 2 j omega. Okay, let me get this out the way. Alright. So now we're going to be cooking here, okay? So let's see here. Actually, whenever you plug in either one of these values, plug in either one of these values, this is actually going to equal 0. So 0 minus 0, okay, minus the integral 0 infinity e to the t for, we're just going to save us a bunch of time here and actually evaluate this interval. E to the t for j minus 2 minus j omega, all divided by for j minus 2 minus j omega squared. Okay, plus, don't forget your 1 over 2j, plus, same thing here. Whenever you plug in either value, it's going to be 0, okay? And if you're, actually, I'll just explain why, okay? So, yes, t would be infinity, but e to the negative infinity is going to be 0, so that cancels out. And also, when you plug in 0 for t, it becomes 0, okay? So that's going to be 0 minus 0, okay? Plus, let's actually evaluate this. E to the t minus 4j minus 2 minus j omega, all divided by minus 4j minus 2 minus j omega squared, okay? Let's see, let me make sure I'm doing all this right here. Okay, so these are going to be evaluated 0 to infinity, 0 to infinity. Alright, that's infinity. That's going to, this gives us 0. Because it's negative infinity. Same thing here. Equals 0. But when you plug in the 0, you'll get 1. You get 1, okay? So then it's going to be minus 0 minus 1 all over 4j minus 2 minus j omega squared, plus 0 minus 1 all over negative 4j minus 2 minus j omega squared. Okay. Okay, continuing. Looks like everything is looking right. 1 over 2j. Alright, so this negative is going to turn this into a positive. Alright, so this is what we're looking at here. 1 over 4j minus 2 minus j omega squared minus negative 4j minus 2 minus j omega squared all times 1 over 2j, and that is going to be your final answer. Now, the answer given to us is simplified differently. You can change the negative signs in here, so let's go ahead and I'll show you what the actual answer looks like simplified differently. So 1 over negative 1 is going to be negative 4j plus 2 plus j omega squared. This is going to be plus 1 over 4j plus 2 plus j omega squared. Okay, they just took a negative 1 out of each thing, and then you multiply by 1 over 2j. These answers are equivalent. There's just no need to do one of them. But whatever floats your boat, man. So that is going to be our final answer. Yeah, the long part about this was the integration by parts. No way around it. But the key to this question was realizing that use of t, no matter, even if it's shifted, even if use of t minus 1 means it's going to start at 1 now, right? That'll give you your domain for your integral. Okay, so if you see the use of t, don't freak out about how to integrate it. It's just used as a domain setter. Okay, hopefully this